All right, so this lesson is a continuation of our adding and subtracting linear expressions lesson. And in this case, instead of being given the problems, we're actually going to build them from some word problems. So it's kind of putting those pieces together to help us solve some other problems. So these go right along with what you have in your notes. But I just want to show you how do we use our linear expressions to kind of model what's going on in these problems. So this one says, write an expression for the perimeter of the bedroom shown below. So if you remember, perimeter means to add together all the different sides. So in this case, I want to add together 2x minus 3 plus x plus 4. So you can think of these as each of our different pieces. But now I want to do the same thing up here. I want this side, which is another 2x minus 3. And then I want to add my last one, which is another x plus 4. So if it helps, you can kind of think of each of these different pieces as one of the side lengths, and we want to add them all together. Just like we have with our other linear expressions, we get rid of our subtraction, we make it adding the opposite, and kind of make those subtractions stand out, or those negatives stand out. When we see just x, we put our 1 in front of it. And then because there's nothing in front of any of our parentheses, we don't actually need to do any distributive property. So there's no multiplying going on. I really just want to combine my like terms together. So whenever you write an expression, we always want to put it in simplest form, meaning we've condensed it down or combined together as much as we can. So I have 2x, sorry about that. I have 2x plus 1x plus 2x plus 1x. So I'm adding those together. 2 plus 1 plus 2 plus 1 is 6x. Now I have a negative 3 plus 4. Negative 3 plus 4 is positive 1. Plus a negative 3. 1 plus negative 3 is negative 2. When they have different signs, you subtract and take the sign of the higher number. And then negative 2 plus positive 4 gives me a positive 2. So my expression for the perimeter of this is 6x plus 2. It's combining together the expressions for each of the different sides and then combining those pieces to get our total. Next one. And this one's a little on the tricky side, so be careful with this one. It says the table shows the cost of a sandwich and a drink at a local cafeteria. We want to know how much more does a sandwich cost than a drink? When you see the word phrase, how much more, that's really code for subtraction. You're finding the difference between those numbers. If we want to know how much more expensive one thing is than the other, we're finding the difference between those costs, which means we are subtracting. So how much more does a sandwich cost than drink? That means sandwich is the higher cost, so we're going to put that first. 2x plus $1.50. And we want to subtract the cost of a drink. In this case is expressed using our x plus 49 cents. Remember, whenever we see that subtraction between our expressions, we want to change it to adding the opposite. And we fill in with our 1. I'm going to put my 1 in here as well. And we always put that 1 with a negative to remind us that it's really kind of like a distributive property. I want to multiply that negative 1 times each of the pieces on the inside. That negative gets distributed through to everything. So negative 1 times 1x is negative 1x. Negative 1 times 0.49 is negative 0.49. The other one just hangs out. We haven't done anything with that piece yet. And now I want to combine my like terms together. So 2x plus negative 1x is 1x or x. $1.50 plus 49 or negative 49 cents, they have different signs, so I want to subtract. And I can do a little subtraction off to the side. Got to do a little borrowing here. And I get 101. I'm going to take the sign of the higher number, which was my 105. Or my $1.50, so I'm going to get a positive $1.01. So the difference in the cost is 1x, or x plus 1.01. I'm just subtracting those two expressions. Next one is similar to our first one. It says a rectangle has side lengths of 3x plus 6 inches and 2x minus 4 inches. Write an expression to represent the perimeter of the rectangle. So we are adding together all the different sides. If it helps, draw out a rectangle and label all the sides. I have 3x plus 6, 2x minus 4. But the important part for perimeter is make sure you do it for all of the sides. 2x minus 4. And we want to find the sum of all the sides. We want to add the sides for perimeter. So I do 2x minus 4 plus 3x plus 6 plus 2x minus 4 plus 3x plus 6. So I'm just adding together on the sides. One thing you'll notice is if you think about the first example we did, you remember how I put everything in their parentheses so we could see each of our different expressions. Okay, in this case, since we know we're not multiplying anything and there's no subtractions, we don't have to distribute through that negative, it's okay just to kind of think of these as separate pieces, but without the parentheses, because we know all we're going to do is go ahead and add those parts together. I'm going to get rid of my subtraction, so make it adding the opposite, and then I look for my like terms. I have 2x plus 3x is 5x, plus 2x is 7, plus 3 is 10x. And now I come back and do my constants. I have negative 4 plus 6, that's a positive 2, plus negative 4, 2 plus negative 4 goes back down to negative 2, plus 6 is a positive 4. So I get an expression of 10x plus 4. Now it asks me to do one more thing. It says, well, what if the perimeter really is 94? Well, what that means is my expression, my perimeter, they've said, well, what if it's equal to 94? So in this case, you're really just thinking backwards. What would I plug in for x so that I can multiply times 10 and then add 4 to it to get to 94? Well, think of taking away that 4. What if we just pretended that wasn't really there? And really 10 times something has to give me 90. Well, 10 times 9 would give me 90, so my missing number must be 9. But all we did was we took our perimeter, what we got when we added all those pieces together, and we just set it equal to 94. And then we just did a little mental math to figure out what that missing number was. All right, here we go. It says the table shows some college costs. So we have the cost of tuition, the cost of fees, and the cost of room and board. It says how much is room or tuition and fees together. Well, together means we want to add them together. So tuition is 8x plus 15. Fees are x plus 50. Hopefully you've gotten the habit of every time you see that x, you just throw in that 1 right away. You'll notice I'm adding them together. There's no numbers outside my parentheses that I have to multiply by, so I'm really just combining my like terms. 8x plus 1x is 9x. 15 plus 50 is 65. Now, I can't combine any farther because 9x and 65 aren't like terms, so that's as far as I can go. Next one says how much more is tuition than the cost of fees and room and board. So in this case, I want to subtract tuition away from tuition, I want to subtract away the cost of fees and room and board. So that's kind of like putting these two together. So let's find fees and room and board together. Fees are x plus 50. Room and board is x plus 3, and we want those together. So I want to add those together. So that's 1x plus 50 plus 1x plus 3. Combining like terms gives me 2x plus 53. Now it said I want to find the difference. I want to find how much more is tuition, 8x plus 15. How much more is that than fees and room and board? So what I really want to do is I want to subtract them. I want to find the difference between them. So when I see that subtraction in between my expressions, I know I want to make it adding the opposite. And I always throw in my 1. Now I'm going to distribute that negative through to each of the pieces on the inside. So negative 1 times 2x is negative 2x. Negative 1 times 53 is negative 53. And then the rest of my expression just hangs out. 8x plus 15. But now I'm ready to go ahead and combine my like terms. So 8x plus negative 2x is 6x. 15 plus negative 53. Here, they have different signs, so I'm going to subtract. 53 minus 15. Do a little borrowing here to help me with my math, and I get 38. But I'm going to take the sign of the bigger number, so I'm going to have a negative 38. So you really have to watch those negatives. But you're just using the wording of the problem to tell us which expressions to combine together. Watch for things like how much more is something than the other. That's code for subtracting. And then you just put the pieces together and combine those like terms. All right, we are all done. Now it's your turn to try some on your own.